students, we will do the next question number 10. For that, I would have to draw the figure. You don't have to draw the figure, but since I'm explaining, I need the figure displayed. So I got the axis. This is the x-axis and y-axis. Now we need the circle. So okay, that's the right point. Okay, all right. So let me take that center. This point is A, this point is B. We got a hit from the center to the point A and from the center to the point B. Now this is C and you have theta. Okay, fair enough. So this is the center, or I would say the origin, and this region is shaded. So let me write the question down. The question is as follows. The diagram shows a circle with center C -4,5 and radius √20. The circle intersects at A and B. The size of ACB is equal to theta radian. Now, first question, we are asked to find the equation of the tangent to the circle at the point -6,9. Number 2 is find the equation of the circle, and number 3 is find the theta. Number 4 is find the perimeter and the area of the shaded region. Okay, so we will have to do quite a sum. So let me just make this a little bit spacious. Okay, all right. So foremost, we would be utilizing, or I would say, let me write the following for the solution. Solution: given center is C of -4,5 and radius is √20. Now the equation, we are asked to get the equation of the tangent at the point -6, 9, right? The equation of the tangent to the circle is given by, we got a formula. What is the formula? X negative h times x1 negative h positive y negative k times y1 negative k is equal to r squared, where x1 is the point of contact, -6, and y1 is equal to 9. Now the center is -4 comma k, -4 comma 5, so h is equal to -4 and k is equal to 5. So if we were to take this as 1, therefore 1 is rewritten as x negative of -4 is +4, and you have -6 +4 positive y -5, and you have 9 -5 is equal to r squared. Now the radius is 20, right, root of 20, so r squared is going to be 20. So -6 +4, that's -2. So I'm going to write that as x +4 of -2 positive y -5 of 4 is equal to 20. So this is what we have got. Now I'm going to utilize a new page. So let me flip this and write this system over here. So you got x +4 of -2 positive y -5 of 4 is equal to 20. Now since it's a straight line, let's distribute -2. So it's going to be -2x -8 positive 4 times y -20 is equal to 20. I move this to the other side, and I also move this to the other side. So you have -2x positive 4y is equal to 20 positive 20 positive 8, which gives us 48, and -2x positive 4y. Now we can actually make everything positive for the x component by moving it to the other side. So we would have 2x -4y positive 48 is equal to 0. Probably we can divide by 2. That would give us x -2y positive 24 is equal to 0, which is the equation of the tangent to the circle. Okay, so you can box that result. So that is got. Now we are asked to find the equation of the circle. This is the next part. Okay, finding the equation of the circle with the center. What is the center? Center is -4, 5, and radius is root of 20. So we know the equation of the circle. Equation of the circle to be as x -h whole squared positive y -k the whole squared is equal to r squared. So if we substitute it, h is -4, so it's going to be h, so x +4 whole squared positive y -5 the whole squared is equal to r squared is 20. So you expand this, you get x squared positive 8x positive 16 positive y squared -10y positive 25 is equal to 20, and this is x squared positive y squared positive 8x -10y. We can add these two. That will give us 41 plus 20. Right, so we can add so 20 will come on this side, so 16 added with 25, that's 1, and 41, so this 20 would be -20. So that in turn would give me a positive 21 is equal to 0. Right, this is the rough side. So this is the equation of the circle. Okay, so these are all too simple to do, right? But the most important part is over here. So we will have to now find theta. Now what I am going to be doing is I would have to get theta. For getting theta, I will bisect this theta. Okay, so this would be a bisector. So I will divide this by theta over 2 and theta over 2. Now this is the opposite side. Now this is going to be 90 degree. Now I need to get AB. If I get AB, imagine this is, say, some C. Okay, so if I were to take tan theta over 2 would be opposite side divided by adjacent side, right? So my opposite side is AC, my adjacent side, okay, I already have C here, so I will place this as some D. Okay, so AD, okay, AD divided by CD. So this is going to be tan theta over 2. From here I would extract theta over 2. That's the basic idea. Now for that I need this entire line AB. Now clearly if you were to see here, it's only AB is lying on the y-axis, so that means x is equal to 0. Okay, so let me use this space and write it down here. We observe that AB lies on y-axis, so this means x will be equal to 0 in, say, 2. So I'll take this as 2. So you substitute x is equal to 0, this would be giving us, so therefore from 2 you have 0 squared, you substitute x is equal to 0, positive y squared, positive 8 times of 0, negative 10y, positive 21 is equal to 0, right? So you have y squared negative 10y, positive 21 is equal to 0. I'm going to use quadratic. So that's negative b plus or minus root of b squared negative 4ac divided by 2 times a. So my a is 1, my b is negative 10, my c is 21. So y is equal to negative of negative 10 plus or minus root of negative 10 squared negative 4 times a times c is 21 divided by 2 times of a is 1. So this is going to give me positive 10 plus or minus root of 100 negative 4 ones are 4, 4 twos are 8. So you divide by 2, right? So everything is working out. Now you got 184, so 10, and you have a 6, so 9, you have 1 there. So you got 10 plus or minus root of 16 divided by 2, which is 10 positive. Square root of 16 will give you 4 divided by 2. 14 divided by 2 will give you 7, or 10 negative 4 divided by 2, which is 6 over 2, will be giving us 3. So the coordinates, let me write the coordinates here. So this is going to be 0, 3 and 0, 7. So I need to get the distance AB, right? So I'll be utilizing the distance formula. So distance of AB is equal to root of x1 minus x2, that's 0, okay, 0 squared plus y2 minus y1. So I'm going to take it as 7 negative 3 the whole squared, that is going to give me 4 squared, which is going to give me 4. So AB, distance of AB is equal to 4. I'm dividing it by, actually the division is exactly in the center. So this distance is 2 units and this distance is 2 units, right? Now we already got the the radii, right? The radius is root of 20. That's given in the question. You see here? This is actually root of 20. It's given in the question. So having got that, we now have the values, right? Tan theta over 2 is going to be 2. This part is 2, right? This part is 2. But we have to get this part. I want to get this part. So for that, we need to use the Pythagoras rule. So I'm going to state here. So this is CD is required. So by Pythagoras, what do we have? We got CD squared plus AD squared is equal to CA squared. But CA squared is 20. So it's 20. From 20 we need this part. What is that? This is CD squared. So CD squared is equal to 20. This goes to the other side. So negative. So 2 squared will become 4. Right. So 20 negative 4, that's going to give me 16. So CD squared is equal to 16. Therefore CD is going to give me 4 units. So this part apparently is giving us 4 units. So you got tan theta over 2 is equal to opposite side divided by 4, which is equal to 1 over 2. So tan theta over 2 is equal to 1 over 2. Therefore theta over 2 is tan inverse of 1 over 2. So we need to get this value, tan inverse of 1 over 2. So let's use a calculator. Okay, I've got the calculator. So this 1 over 2 is 0.5. So you press the shift and then tan inverse and then 0.5, which is equal to 0.46. So this is equal to 0.4636. Right. Probably I can place it as 5. 7 is here, so I'll make it as 5. But we need only theta. So therefore theta is equal to, we multiply by 2, and that would give us 0.92729. Right, 729, but you have 5 there, so you make it as 10. So 10 will become carried on to 2, so that will become 3 there. So 0.9273. So that is the value of theta. Okay, so let me block that off. So we got theta value. Now what you can do is, you need to, I have just explained it with the figure. You can exclusively draw the figure over here and extract the value and show it to the examiner. Okay, because I have drawn the figure here, I need to show you the working, how exactly theta is calculated. Okay, now moving on, we are asked to find the area of the shaded region. Okay, now to get the area of the shaded region, what we have to do is, so let me show you the shaded region exclusively. So area of the shaded region, area of the shaded region is equal to area of the sector. From area of the sector we subtract area of the triangle. Okay, you see here, this is the sector, this entire thing is a sector. From sector we take away the triangle, the entire triangle we need to take out. Okay, so foremost I'm going to give you the sector area. So let me find the area of the sector. Area of the sector as a formula is half times r squared theta. Now which is equal to 1 over 2 times r squared is 20. My theta, we got the value of theta is 0.9273. 0.9273. 2 divides here 10 times. So you have 0.9273 multiplied with 10. That means the decimal will move towards the right. So this is going to be 9.273. This is the area, right? So I'm just going to take it as square units. Area of sector. So that's one part. Now we need to move to the next part. So sector area is got. Now we have to get the area of the triangle. Now you see the triangle, you have the base and you have the height. So area of triangle, I'm going to calculate the triangle ACD is equal to half times base times height. Now we need to get the base, right? So what is the base we found? The base we found as 4 units. We already got 4 units here, you see here. So half times 4 units times the height is 12 units, 2 units. So 2 gets cancelled, you get 4. Now also the area of BCD will be 4 units. So therefore the total area of the triangle, ACB will be 4 plus 4 is equal to 8 square units. Okay. Now if we had already calculated the sector area, so therefore the area of the shaded region, is equal to sector area is 9.273, right? 9.273 minus area of the triangle 8 units, which is going to be 1.273 square units. Okay, that's the area of shaded region. Okay, you can box the result. So we got one more part to go. This part is perimeter of the shaded region. When you talk about the perimeter, we are actually looking at this arc length plus this straight line. Okay, so we need to get the arc length. So arc length, let me take this as say some AEB. So arc length is required. So arc length AEB is equal to, now there's a formula, L is equal to R times theta. This is a formula. So R is root of 20. Now we got the value of theta. Theta is 0.9273. So substitute that 0.9273. So use the calculator. You have to take the square root of 20. That's 4.4721. This multiplied with 0.9273. 0.9273. That is going to be 4.147. Okay, so this is the length, arc length. Now we got arc length and we have to add AB. AB is 4 units. Okay, so since AB is equal to 4 units, therefore perimeter of, so we are looking for the shaded region. So shaded region, I'll just write it as shaded region, is equal to 4.147 plus 4, which is equal to 8.147 units. Okay, so that completes the solution for this question.